Ladies and gentlemen, good afternoon. Please take your seats. It's time to start. First of all, thank you very much for coming to our symposium on interactions between pollination service and agricultural practices. First of all, we have to recognize the financial and organizational support of A.B.E.L.H.A, which is the Brazilian Association for the Study of Bees, for what we ask Mrs. Ana Lúcia Assad. Please, Mrs. Ana Lúcia Assad, Executive Director of A.B.E.L.H.A. Please stand up, just in behalf of all of us. Thank you very much for your support of the organization. So, we will have some small change in the schedule of the symposium. The presentation regarding the impact of the global climate change and the pollination will not be present. Instead, it will be substituted by a wrongly withdrawn presentation, the sublethal impact of insecticides to pollinator by Dr. Roberta Nocelli, which will be the last one during this first part of the symposium. And I have to tell you that I always have problem to squeeze presentation inside those 15 minutes block. So I decided reading the presentation in order to keep in time. So now let's start our symposium. I will make my introductory speech. Pollinators provide a key ecosystem service by pollinating not only crops but also wild plants. It is estimated that 35% of the global crop production, as well as 85% of the wild flowering plants, relies to some degree on pollination. Not only bees are responsible for pollinating plants, but this group is widely recognized as the most important one on a global scale. So, in this presentation, we will focus on bees, despite not all bee species act as pollinators. More than 20,000 species of bees belonging to several families of the order Hymenoptera were already described, and an undefined number are still unknown. Only my country, Brazil, almost 3,000 species of bees were identified, and 80% of them are found in the Amazon forest. Regardless of their importance to human well-being, biodiversity in a broader scale, and ecosystem service like pollination on a more restricted analysis are adversely affected by anthropic activities. An assessment conducted by the World Resource Institute in 2005 estimated that 60% of the ecosystem service, including pollination, are being degraded or not being regenerated quickly enough to meet the demand. This way, there is no wonder on the very high level of worry with the decline of the bee population on a global scale, hence the effectiveness of the natural pollination service that may pose a significant threat to human and natural well-being. Anyway, as a matter of fact, should be stated that the number of beehives has increased globally over the past 50 years, and the decrease of the hives is limited to some European and North American countries. The Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Service, IPBES, that currently has 124 country members, was established 4 years ago as an independent body linked to the United Nations with the mission of assessing the state of the planet's biodiversity, its ecosystems, and the essential service they provide to society. According to IPBES, a growing number of pollinator species worldwide are being driven toward extinction by diverse pressures, many of them human-made, threatening millions of livelihoods and hundreds of billions of dollars worth of food supply. The IPBES mentions some important statistics to illustrate the interface between pollination service and agriculture. Let's closely look to them. There are estimated 20,000 species of wild bees, along with a lot of species of butterflies, moths, wasps, beetles, birds, bats, and other vertebrates that contribute to pollination. 75% of the world's food crops depend, at least in part, on pollination services. The annual value of global crops directly affected by pollinators may reach up to $577 billion. The value of the pollination service is estimated to be almost 200 billion euros only for Europe. In the past 50 years, the volume of agricultural production dependent on animal pollination incremented over 300%. Almost 90% of wildflowering plants depends to some extent on animal pollination. Annual honey production from the western honeybee reached 1.6 million tons. 16% of the vertebrate pollinators are globally threatened with extinction, and more than 40% of invertebrate pollinator species, particularly bees and butterfly, are facing extinction. In a recent paper, Brown and collaborators summarized a suite of drivers leading to this population decline, which include: first, habitat loss and simplification of ecosystems, reducing shelter and the amount, quality, frequency, and diversity of food resource required by pollinators. Second, the introduction of invasive species to the environment, disrupting the equilibrium between plants and pollinators. Third, eruption and spreading of new and old pests, affecting both native and domestic bees. Fourth, negative impact of pesticide application, including acute and sublethal adverse effects on pollinators. Fifth, global climate change, making some environments unsuitable or at least less suitable for pollinators. Besides these key aspects, it is worthy to mention other sources of negative impacts upon pollinators, especially cultivated bee species. Among them are genetic breeding, several stress to which bees are submitted, like nutrition, transportation, and temperature. Non-adequate bee colony management practices, especially from the colony health standpoint, and over-reliance on domesticated honeybees for pollination, which may compete with wild pollinators for scarce resources. Habitat loss, or its simplification, is a consequence of the expansion of the economy, including the need for more space for housing, industries, leisure, and the most important one, for agriculture. In the case of agriculture, the habitat loss results from the expansion of the global cultivated area, which is closely linked to the growing population, targeted to reach over 9 billion people in 2050, and the increasing per capita income causing a continuous rise in the demand for food and other agricultural products. Loss of habitat reduces the amount of resources demanded by bees, resulting in lower environmental capacity to support bee population, a major reason for the bee decline. Bees demand a diversified diet to obtain the basic nutrients they require for the best individuals and colony development. The loss of habitats or its simplification reduces the chance of bees to get the nutrients they require. The intensification of the agriculture in subtropical and tropical regions imposes that soils sometimes are covered with crops during the entire season, extending monocultures in space and in time. Some years ago, the interval between cropping seasons allowed weeds and other plants to occupy the resting area, with partially overlapped schedules of flowering, offering pollen and nectar for the bees. The pursuit of higher yields demands more frequent, if not more intense, use of pesticides. These chemicals, in particular insecticides, have a certain degree of impact upon non-target insects, like natural enemies, the pests and the pollinators. Nowadays, one of the major challenges we face is how to control crop pests with the minimum impact over the ecosystem services. The health of pollinators is another key aspect to be considered. During the last decade, the so-called colony collapse disorder, the CCD, triggered a global wave of concerns on governments, environmental agencies, universities and research institutions, NGOs, industry growers, food processors, and the civil society. It was deeply discussed the decline of the population of bees, hence the pollination service and its consequence for food production and the wildlife. This discussion consolidated in the public opinion the awareness for the need for urgent actions to stop and revert the process. The CCD is over, but remains still unclear, and there is not a single reason to explain the phenomenon, probably a multivariate one. The recent CCD was not the only episode of mass bees disappearance that ended without a reasonable explanation. There are several records of similar episodes on the scientific literature, going back as early as the beginning of the 19th century. These cases were described with mere speculation of possible causes, not followed by a scientific demonstration. Pollinators' health are frequently associated with CCD or bee decline. Insects, mites, fungi, viruses, bacteria, and a group of vertebrates act as pests of pollinators or honey stealers. The major pests of rearer bees are pretty known. It would be feasible to manage the health of domestic bees colonies, keeping them within adequate standards, but it is almost impossible to do the same when wild bees' health is involved. When bee colonies are used to supplement pollination service on large commercial orchards, they suffer two particular types of stresses. The first is the transportation stress, as the bees travel during several days along thousands of kilometers, closed on the beehive boxes under adverse conditions. The second is the exposition of the stressed colonies to a new environment to which they have to quickly adapt. It is already known the negative impact of temperature, but as far as global climate changes are concerned, we do not know exactly what will happen. Nevertheless, we can anticipate some of the impacts using modeling techniques, combining direct climate impacts over the biology, ecology, and behavior of pollinators with ones affecting the plants that provide pollen and nectar. Up to now, scientists have established that climate change has led to modification in the distribution of many pollinating bumblebees and butterflies and the plants that depend upon them. Governments, the academy, NGOs, international organizations, and other stakeholders are not only discussing the pollinators' decline and its fundamentals, but are also looking for proactive policies, technologies, and attitudes aiming to reverse the trend of the recent years. A closed focus has been put over agriculture, aiming to develop production systems more favorable to pollinators. The recommendations are based on the common background of incentivizing the adoption of good agricultural practices, looking for a sustainable agriculture which take advantage of the natural service. In the last February meeting held in Kuala Lumpur, the IPBES members agreed on a set of specific recommendations to manage the situation as follows: maintaining or creating greater diversity of pollinator habitats in agricultural and rural landscapes, supporting traditional practices that manage habitat patchiness, crop rotations, and co-production between science and indigenous local knowledge, education and exchange of knowledge among farmers, scientists, industry, communities, and the general public, decreasing exposure of pollinators to pesticides by reducing their use, seeking alternative forms of pest control, and adopting a range of specific application practices, including technologies to reduce pesticide drift, and improving managed bee husbandry for pathogen control, coupled with better regulation of trade and use of commercial pollinators. And as I wrap up, we can summarize that several environmental services are under threat due to anthropic influence, being the pollination service one of the most affected. We have solved just part of the scientific puzzle to understand causes and consequences of the pollinators' decline. According to FAO, along the next 3 decades, there will be a 70% increment on agricultural output, with the potential to reduce the habitats for pollinators and adversely impact them by misusing agricultural practices. This way, we understand that it's paramount to look for policies, technologies, and attitudes to counteract the recent trend and initiate a recovery of the pollinators' population and the level of natural pollination services in order to support the estimated increase in the demand for food and other products of agriculture. So thank you very much for your attention.